It's lovely to be here. I have a little bit of mixed emotions. I thought, so as you can see, my title is Bring AI-based search to your web app. So I had mistakenly assumed I'd be the first person to introduce AI to your life and world, but sadly that was Todd, but that's okay. It's not so bad being second. My name is JP. I work for a company called Weaviate. We build a vector database, and I'm actually quite glad to be following Todd because there's only so much you can talk about in half an hour. So thanks, Todd, for the amazing talk about large language models. And I'll be touching on that aspect of AI as well as the search aspect and building on that. So I think the word AI can bring a little bit of mixed emotions these days. It can mean a lot of different things. And to a lot of people, it's become a buzzword that they attach to their product, service, and what have you. So what I wanted to do before I get started was to talk more concretely about what I mean by AI in this context. So I'll be talking about AI in two different ways today. One is AI search. And as we progress through the talk, I'll talk a little bit less about AI search and more about vector search or semantic search, which is what I mean by when I say AI in that context. And of course, I'll drill a little bit into the why and the how of the magic that makes the AI search work. The other part is actually the generative search or generative AI aspect, which builds nicely on to Todd's talk about large language models. And I'll talk about retrieval augmented generation, which is RAG, and that's the amazing thing that you get when you combine AI search with large language models. Now, I'm not going to be talking about how vector search works and all of its glorious details and model architectures. Because quite often you can get into the weeds and people will say, oh, this is very simple, here's a 45-minute talk, and it's just, yeah, it's too much. Again, I only have half an hour. And it is not a talk where I'll be teaching you a whole lot of syntax about how to use a particular library or software, right? So the idea today for me is to demystify a lot of this technology so that you can integrate it into your tooling and use it to generate value for the end users for your technology. So here's my goal, right? It's to encourage you to consider or to actually add AI to your tech stack or the web app in more particular detail. Let's get started with the demo first. I might just move this mic a little bit further away from my mouth. Cool. Let's get started with the demo first, right? And I've got a fairly simple web app here. I'm sure you're very familiar with the concept of a search bar, so I won't bore you with that. But what it is a fairly simple app with a database or data set of trivia items. So if you really want to know, the data set comes from an American quiz show called Jeopardy. Please put your hand up if you're familiar with the TV show. OK, so that's a non-zero number. I'm pretty comfortable with that. But the idea is that this is a trivia set of questions. So if you imagine just a pair for each object, right? I've got a question and an answer and some metadata like, what category does it come from, how much points was it worth for the contestant, and so on. But again, the main point is that you've got a series of questions and answers that, just like you would at a trivia night. So let's look for questions like something about cats. And if I run that search, I get these entries. So the first question is about a fat and sagging striped house cat, and the category is rhyme time. So the question needs to be, or the answer needs to be something that rhymes. It's a flabby tabby. And what is the largest member of the cat family? You might know this. It's apparently the tiger. So this is a keyword-based search. And if you've used things like AltaVista back in the day, you might be familiar with some limitations of keyword search, right? So if I say words like kitten, I don't get any of the same results, even though we as humans understand that these mean the same things. So I must use, if I'm using keyword search, I have to use the exact same words that I use to store in the database as I do for the search. Let's see if we can fix that. Here's my source code. Again, this is not for you to remember the actual syntax. At the end of the presentation, I'll have a QR code with a link to a GitHub repo, which will have all the source code for the presentation and some additional resources as well. So, relax and just enjoy the journey with me. What I'm going to do is to change this particular syntax so that it goes from a keyword search, which is what it is now, to a vector search. So I'm going to comment that out and say, let's say with near text concept query string. So what I'm doing is where I had the query string, which is the user input in the, from the web front end, to the keyword search. Now I'm passing it to a vector search or semantic search. And let's reload our app. And if I search for the word cat, I'll get similar results as before. You might notice it's a slightly different set of results. And if I search for the word kitten, as I searched just earlier and got 0 results, I essentially get the same results as I did when I searched for the word cat. So I would think that is a far more desirable outcome than searching for the word that has the same meaning, but will not produce the results that you want. So this is a fairly simple example of a vector search or semantic search, and I'll distinguish between the two in a second. And here's the thing about search. To get good results, you shouldn't need to know any magic words. And with semantic search, you absolutely do not. These words were taken from a blog written by David Haney and David Gibson on their Stack Overflow blog just a couple of months ago, when they were talking about integrating Weaviate into their search and evaluating semantic search for their purposes. And for a site like Stack Overflow, it's of course very, very important for their users to be able to find the results that they're after without knowing the particular keywords that the writer might have used. So that is semantic search. But how does it really work? I haven't explained any of that yet. A key thing to understand about semantic search is that when you have a particular word, phrase, sentence, or so on, the meaning is what gets vectorized. So in this demonstration, or in this example, you'll see words like wolf, dog, and cat. And if you can't see that on the back of the screen, what I've got is a series of objects in 3D space. Some of them are labeled. And on the left-hand corner, I've got wolf, dog, and cat. And on the right-hand side, some of the dots are labeled banana and apple. And the words wolf, dog, and cat, so of course all animals, are grouped in one side, whereas the fruits are grouped on the other side. So hopefully that gives you an idea that some sort of similarity is involved in where these objects appear in this 3D space. And if you can put similar objects closer to each other in space, you can perform similarity searches. So when I put in the word kitten or puppy instead of the word dog or cat, you can perform you can convert those inputs into a vector and perform these searches to find related or similar objects, even though you don't know any of those magic words. Okay, that's great, but what the heck are vectors anyway, and how does that work? Just as out of interest, who's used vector databases or vectors in their work here? Cool. Again, a non-zero number. But this is an interesting thing as I perform these talks or give talks, because even amongst data scientists who's dealt with different machine learning models, they haven't all dealt with vector embeddings and dense vectors. So this is hopefully interesting to you as well. So let's step back a little bit and talk about vectors. Are there other areas where we quantify similarity in everyday concepts? And the example I like to use personally is colors. I think many of you would have used the RGB system. So can I get another show of hands if you're familiar with the RGB system? Fabulous, that's what I was after. Listen, I was going to be in a lot of trouble if you all said, what the heck is an RGB system? And I was going to have to go back a number of steps. But you're familiar with the RGB system, right? So you got 3 numbers, integers, that represent how red, how green, and how blue something is. Right, so 25500 is red, 80, 200, 120 is emerald, and so on. I won't bore you by reading a whole bunch of other numbers out. But if you organized colors by just those numbers and plot them into 3D space like I've done here, a kind of a cool thing happens. Even if I didn't have, like, so the dots here are not organized by colors. They're organized by their red, green, and blue values. But what you end up getting is this 3D representation where similar colors end up closer together in space. So have a think about that. And then now, let's extend that concept. I'm going to hand wave a tiny bit and skip a little bit of details. But if you imagine that now, instead of having 3 dials, right, one for red, one for green, one for blue, having hundreds or thousands of these numbers, how many ideas or concepts could you represent this way? And instead of going from integers or 8-bit integers to floating point numbers, so you have infinite adjustability in these dials. If you do that, a magical thing happens, that you can represent complex meaning, complex nuanced meaning of words, sentences, paragraphs, and more in these series of numbers. So here's an example of me vectorizing some random headlines. So here's one about 3 people getting rescued off Australian coast. The full headline is actually about a shark attack, which is like possibly the most Australian thing ever. So that can be vectorized into a series of numbers. And you can do this with any text, right? So here's the second one about tourists and dingoes. Again, extremely Australian. And the last 2 are about star football players, Sam Kerr, who's the Australian captain, and Mary Earps, who's the English keeper. Each of these texts can be vectorized into a series of numbers I've done here. Okay, so you might be thinking, so what? You got a series of numbers instead of a series of characters. Who gives a, whatever. What you can do is, once you have a series of numbers, is to quantify similarity. So if those series of numbers capture meaning in a, I wouldn't say accurate, but in a representative way, because you do make some choices as to how you vectorize these things, you can now determine how similar each of those concepts are. So this is a similarity matrix of those 4 headlines. And you'll notice on the upper left quadrant and the bottom right quadrant that the colors come out to be more red. And that means that the model's identified that the first 2 headlines about Australian tourism are very similar to each other, and the bottom 2 about star football players are similar to each other. And across these subgroups, you get these bluish colors indicating that the similarities are lower. And this is at the heart of how vector search works. So you go from these unstructured data, typically of objects, you convert them into vectors, and that's what enables similarity search. And again, how do you get those vectors? And that's the magic of these modern deep learning models that Todd was talking about earlier in terms of large language models. They share a lot of the similar kind of architecture or the components that go into it. But as practitioners and as developers, you don't necessarily need to know exactly that architecture or what's going on behind it. What's important is to understand that that's the process behind the magic, and that you can choose different models to suit your purposes, as you'll see. So where do vector databases fit in this picture? Well, they are vector first. So they index data by vector to allow for fast retrieval of data as we go. And the question I get a lot is, hey, how hard is that to use? Especially if you're not a data scientist. So here's my Node.js script of basically the entire backend. Again, this is not designed for you to read. I'm sorry, the font is very small. But this is the entire script that I've used to ingest around 10,000 objects of data of the quiz items, which will turn the objects into vectors at import time and prepare a server that I can send requests to for those similarity searches. OK. And what's happening at the front end? The app that you just saw earlier is a React app. And there's really 2 things that go on here in regards to what's happening in terms of vector searches. So I'm connecting to my database, which is the code snippet you see here. And it's roughly about 5-6 lines of code. And this is the entire query. This is all you need to do to perform a vector search. It's like 5 lines of code, and you say, hey, I want to perform a near text search to compare my objects against the input string. That's all there is to it. And the cool thing is, if you can vectorize text, you can probably imagine that you can apply this technology of capturing some sort of meaning to other media or modalities. So some models can even vectorize images, videos, text, accelerometer data, thermal data, and so on. So let's have a look at another cool demo. Oops, giving away the lead a little bit there, but that's fine. So in this demo, what I'm going to do is to search for images using text. So I search for the word dog, airplane, I get a picture of a plane, or a city. And I was showing this to my wife yesterday, and she said, oh, so that's just like Google image search? And I went, I guess that's true. How easy is it for you to add Google image search to your web app, though? It's probably not the easiest thing to do, right? Except it is. And another cool thing, which you might have seen if you saw me before I refreshed this thing, is that I can use multilingual inputs. And is that correct, by the way? Fantastic. There you go. So this app is not only multimodal, but also multilingual. So I can ask it questions in whatever languages, across modalities, as in I can search for images using text, as I've done here. I could go the other way to search for text objects using images, or images across images, and you get the idea. Now, that's using a different model to the first model that you saw with my quiz items, and this is where choosing the right model for your use case comes in handy. So certain models, for example, would be able to speak, like that are designed to be multilingual, can speak 100+ languages. So think about what that will let you achieve. Let's say if you have a data set of customer information or feedback in many different languages. Now, you don't have to standardize that into one language. You don't have to post-process it after retrieval from your database. You can just go from a query in whatever language to the relevant objects without transforming your data at all, except for, of course, generating those vectors. I think it's pretty cool. So that's vector search at its heart. And all you're doing is the same workflow as what you've done with traditional databases. So instead of using a traditional, say, SQL or NoSQL database, you're using a vector database that will understand your query in whatever modality or language you want based on the model, and you retrieve those documents. Let's do some cool stuff, though. I have this slide in quite a few of my presentations, and the question is, have you used ChatGPT? With the answers yes and yes. Every so often, I do get someone who says, no, I've not used it. So if you haven't used it, can I get you to raise your hands? OK, we should talk after, because I'm really interested to know why people haven't used it. And I've got someone in my team as well who hasn't used it. And I keep asking him, hey, have you tried it? And he's like, no, no, no. And I think at some point, I'm convinced he's just saying that to annoy me. But anyway, that's just my own issues. These days, any app with AI seems very sexy. And I don't know if you've seen this phenomenon before, but a lot of the perception is that, hey, does your app have AI in it? Look, I get that. As an app developer, it might not seem ideal to be going after the latest sexy thing. But sometimes being sexy is good, right? So, and as I'm trying to show you today, it's quite achievable. So let's try and add some sexiness to our app as well. Because adding these amazing capabilities of large language models to your data, to grounded, as we talked about all morning, leads to some really great results and very powerful sort of user engagement and love. So here's my second demo, which is going to be all about retrieval augmented generation. So let's go back to our trusty VS Code. And this query here is the exact same query as the one that we ran just earlier. All I'm going to do is to add a prompt. So again, thanks to the last presentation, I don't have to talk about what a prompt is. This is great. What I'm going to do is to just add this method, say with generate, and say single prompt. And I'm going to ask the model this. So I'll copy and paste that. And I'll just talk through what it's doing. So what I'm going to ask is this: provide a short hint for the user to help them answer this question. And the question is in braces. The hint should lead them to braces answer without mentioning it. So you can probably guess that this is some sort of templating language, and that's exactly what's going on. What I'm doing here is retrieving the results from our vector search and prompting a language model, GPT 3.5 in my particular case, with it. And these templated portions like question and answer are going to be swapped out with the actual data of the question and the answer. So let's see how that modifies our app. So if I place that, and let's go for something longer, intergalactic. So again, even though I've used the word intergalactic and it doesn't appear in the question, I get the question sort of galaxy or space related. And I get this new column on the right with the hint. It's the celestial pathway here where our solar system resides. And I want to emphasize that this data, or this column, is not being retrieved from the database. What's happening is that the data you see on the left is being retrieved from our database, and that's being sent to GPT 3.5 along with the prompt that we provided. And this prompt can be anything. I'm going to do another risky thing and ask it to do something in a language I don't speak. Translate the following into Bulgarian. Yeah, this is just playing with fire, isn't it? What could possibly go wrong? Oh, that's a typo. Oh, let's see if that works. So another thing about language models that they are, about vectors, is that they are robust to these things, typos, as I tend to make here. So I'm missing a G in intergalactic, but it's able to tokenize the word into smaller subword portions so that it's understood enough of what I was trying to say, even though I was being incredibly incompetent and made a typo for 12 characters. But that's okay. And it's gotten the right answer. And now, I not only have a version of this quiz that's robust to my silly typos, but also in, hopefully, the correct Bulgarian. Yes? Fabulous. So, yeah, and then think about the possibilities things like this enables. How often would a workflow involve retrieving massive amounts of data, having to summarize it, translate it, or extract information from within? All of that can be automated, and without necessarily all the problems associated with large language models and their hallucinatory tendencies. So, what we've done here is to get a vector search workflow and add a large language model to it. And that's what retrieval augmented generation is. You might also see the terms like generative search or in-context learning. They can mean slightly different things depending on who you talk to and the context. But basically the idea here is that without having to retrain your language model, which is costly, difficult, and quite often time-consuming as well, you can do this and ground your model in fact that you might have. And also, another benefit of doing this is that you can validate the results because you have the data that you provided to the language model. So if you want to audit where this information came from, that becomes far easier than having to dig into the 550 parameters that don't even really mean anything because it's not really directly transferable to, hey, what was in the training corpus and how does that translate into weights in my model and so on. So that makes the model workflow or the generation workflow a lot more transparent. I should note that retrieval augmented generation is inherently a multi-step process. So again, what it's doing is retrieving the data from our database, sending it to a large language model, and serving that as well as the response. So you get the original data along with the data from your database. Again, how hard is it to use? It's basically the exact same query as you saw earlier. The only difference I've got here in this query is that I've added the prompt and obviously the one other method. So it's basically one more line of code. It's pretty neat. I've got a bonus demo, which I think I do have time for, so let's do that. You'll see I've got another bonus prompt here, and it says, hey, write a tweet with a bunch of emojis using these facts promoting a trivia board game. Make up a name for the game. So let's see how that goes. Another thing I've got here is that in our trivia question, I can now type in an answer. So what is the name of our own galaxy? Let's say Super Mario Galaxy. Great game. So if I type that in, I get this particular response. It says, hey, Super Mario Galaxy would not be deemed correct as the answer to this particular Jeopardy question. The correct answer is the Milky Way. This is another. This is based on another response from GPT 3.5. What I've done is I've sent the question, the answer, some context in terms of the prompt, as well as this user-provided answer to the language model. And I've gotten this answer back with negative feedback about why it's wrong. And you can also see that there is a vector distance versus the correct answer, which of course is the Milky Way. And that tells us that that's going back to the idea of vector search and vector similarities. And I've got this amazing ad for this trivia board game called Galaxy Quest. So you can do all of these things with just a few lines of code. And what else does using a vector database get you? It's really dealing with these things at scale. If you think about how many documents, paragraphs, or sentences exist in your corpus of all your data stores at work, and if you have to represent each one as a vector, how many of them would you need? You're quite regularly dealing with millions of vectors, if not billions. This creates challenges because vector comparisons are not the cheapest compute operations. And also you need to manage each of these rows of data. And that's where vector databases are really, really handy. So quite often, if you're dealing with hundreds of millions of data objects, we actually ran a demo last year, which was just short of 1 billion objects in our data set, and we're still running lightning-fast searches, which was really, really cool to see. You can try running that in a NumPy array, but good luck to you. You might be there for a few years. So let's just recap. Vector databases like these provide AI-first tooling. And a key reason for providing that isn't because you can't do these things outside of vector databases, but it makes that job easier, faster, more convenient, and scalable. To make your life easier as a builder. Again, all of the demo you saw earlier was created on the back end with just this script, and that'll create a database that you can send requests to from the React app. And basically, most of the React app is just me. So full disclosure, I'm mostly a Python developer, not a front-end person. So most of the code you see in the demo will be me struggling with CSS, layouts, React, and all of that good stuff. And the actual query is just these few lines of code, which was, even as me, a person building this demo, really amazing and made my life easier so I can struggle with the important things, which is how do I center flexboxes? But that's fine. So here's the recap. If you want to take a picture of any slides, this might be the one. So the message to you is that vector databases provide this AI-native tooling. Vector searches can provide everything from semantic searches to multimodal searches. And you have to choose the right model to provide those capabilities so that your model understands the right languages, the right input media, or even across multiple sets of these media. And the cool thing, which is a thing I really like to play with in these demos, is the large language model integration. And you can play with different models as well because there are different options for how you integrate them and with which model your integration is performed. And lastly, not least, it also helps you to scale to production because, again, the scale at which you're playing with these things is not trivial. So that's it for me. Thank you very much for your time.